Hello. So our topic for this morning, for this day, is all about the definition of RAE. What is RAE? So it is also called rational algebraic expression. Okay? So how can we define RAE or rational algebraic expression? Okay? So if we are going to recall our topic last week, it is all about polynomials. So we will just make polynomials more complicated and it will become now rational algebraic expression. Why? Because we are now having the numerator and the denominator. Okay? So how are we going to distinguish rational algebraic expression? For example, if you are going to have rational algebraic expression in the form A over B, this can be an example of RAE because it is expressed as a quotient of two polynomials. Why? Because if we are going to denote A, so it is an example of monomial and monomial. Also, our denominator is also an example of monomial. So that's why it is an example of RAE. Okay? Next, we can also have an example in the form x over x plus 2. So in this case, we have here the numerator which is a monomial and our denominator is in the form of binomial. So still, it is an example of RAE. Next, if we have x plus 5 all over x squared plus 10x plus 25, it is also an example of RAE. Why? Because our numerator is an example of binomial and our denominator is an example of trinomial. So again, when we say RAE, it is always written in the form of fraction. Okay? So the keywords RAE or rational algebraic expressions are always in the form of fraction. Okay? But we have to take note, for example, we have here P over Q, that both the numerator and the denominators are both polynomials. Okay? So, just like what I have given to you, polynomials are in the form of monomial, binomial, and trinomial. And you have to take note also that our denominator Q should not be equal to 0. Because if the denominator is 0, therefore, you cannot obtain any answer if you are going to divide. Okay? So, how are we going to rewrite or translate verbal phrases into rational expressions? For example, I have given you the quotient of 3x and 4y. Okay? So, as you have seen, the word quotient, you have to take note of this because you have to determine how are you going to rewrite this phrase to mathematical symbol. The quotient means division. So, therefore, you are going to use fraction bar. Okay? So, just like what I have given you on the examples earlier, rational algebraic expressions are always written in fractions. So, that's why the quotient here means you are going to use the fraction bar. So, the quotient of 3x and 4y. Okay? So, we have here already the translated form of the quotient of 3x and 4y. When we translate the symbol is 3x over 4y. Okay? So, let's have another example. If I have given you the statement or the phrase, the sum of A and B divided by their difference. So we have here to take note of the operations or the clue words or phrases that we are going to use. So I have here the sum, I have here divided by, and I have here the difference or the difference. Okay? So let's take note of first of the sum. Sabi, the sum of A and B. So we have here the sum of A and B. And then, it is also said, divided by. So, you can have here the fraction bar. Their difference. So, therefore, difference means subtraction. So, that's why we have here, their difference means A minus B. So, here is a translated form of our phrase into rational expression. Okay? For another example, let us have the fraction whose numerator, okay, so again, the fraction whose numerator is 3 more than the denominator. And for example, our denominator is represented by y. Okay? So again, the fraction whose numerator is 3 more than the denominator y. So for us to translate this to rational algebraic expression, we all know that the fraction is always having the fraction bar, having the numerator and the denominator. So let us have here the abbreviation, kunwari, numerator represented by NUM, then we have here the denominator DAM. Okay? So the fraction whose numerator is 3 more than the denominator y. So on our given statement or phrase, so we have here, ang denominator daw natin is y. So therefore, you will have here y. And then, it is said that the numerator is 3 more than. Okay? So the phrase more than means addition. Our denominator is y. So therefore, you can have here the y is our denominator. More than means addition. And it is 3 more than. So you will have here y plus 3. Okay? So therefore, we have here the translation or the symbol of y plus 3 all over y. From the given statement, the fraction whose numerator is 3 more than the numerator y. Okay? I hope you get it. But, if you are given the statement that the fraction, so again, the fraction whose denominator, so this time, denominator is on the first part of the statement, is 3 more than the numerator. For example, it is represented by x. Okay. So this time, we are going to take note again that you are going to find for the fraction. So you have the fraction bar. The fraction whose denominator is 3 more than the numerator x. So it is already given that our numerator is x. And then for you to find for the denominator, you will have here 3 more than our numerator is x. So that's why we have x over x plus 3 for our translation. Okay? So, is there any question? I hope you understood about how you are going to define and how are you going to illustrate rational algebraic expressions. Goodbye for now.